All right, welcome. In this video, in the next couple, we're going to go over a section 4.1 from the Lock 5 textbook that is introducing hypothesis tests. But first, let's do a quick review question. A 99% confidence interval is going to be wider than a 95% confidence interval, narrower than a 95% confidence interval, or the same width. All right, I hope you picked wider. And it's wider because a 99% confidence interval contains the middle 99% of all the bootstrap statistics, while the 95% confidence interval only contains the middle 95%. So the 99% is going to contain more statistics, so it's going to be wider. Okay, so we're going to start with the example involving ESP. ESP is extrasensory perception, or sixth sense. So, do you believe in ESP? Well, the answer is yes or no. Let's look at some data from the last couple decades. 1990, 1996, and 2000. The blue bar is those that believe in ESP, and it hovers around 50%. Each of these three polls. So I want to know, or want to go over, is how could we test ESP? Well, one way is with this idea called Zener cards. It's named after a psychologist. So there's 5 cards, 5 different shapes. And you can see the picture right here. A subject draws a card at random and telepathically communicates this to someone to see if they would guess the symbol. If you've seen the original Ghostbusters, there's a version of the Zener experiment with a shock for those that got the guess right or wrong. Okay, so if we take 5 cards with 5 different symbols, supposing there's no such thing as ESP, what proportion of guesses should be correct? And the options are 0, a quarter, a fifth, or a half. Well, if there's no ESP, that would mean that everyone's guessing at random. So you should get right about 1 out of 5 times. So if you have 10 cards, you should probably get about 2 correct, and so on. But of course, statistics vary from sample to sample. Maybe get unlucky or lucky playing this Zener card game. So the population proportion should be 1/5 overall, but not every sample will be exactly 1/5. So we want to talk about in chapter 4 is how do we determine when a sample proportion is far enough above 1/5 to provide evidence for ESP. We say we want to know if someone gets 3 out of 10 cards, right? That's 30% instead of 20%. Is that far enough, or is that just kind of lucky that they got 3 out of the 10 instead of 2 out of 10? So a statistical test or a hypothesis test, a test for significance, is used to determine whether results from a sample are convincing enough to allow us to conclude something about the population. So you kind of want to think your population is on trial, something about the population, a mean or proportion, difference of proportions, and your sample is going to be the evidence. And the question is the evidence going to be strong enough? So in this ESP experiment, we want to use sample data to determine whether the population proportion of guesses is actually higher than 1/5. So p hat would denote the sample proportion of correct guesses in an ESP experiment. So suppose someone were to run a sample and have someone else guess on these cards, and here's 3 possible sample statistics. So 0 cards right, 1 out of 5 cards right, 1/2 of the cards right, or 3/4 of the cards guessed right. Which of these would be the strongest evidence for ESP? And that would be 3/4. 3/4 is the highest, so this would provide the strongest evidence that ESP does exist, that someone does have extrasensory perception. So we're going to set up these statistical tests using hypotheses. So these are framed in terms of 2 competing hypotheses. The null hypothesis, which is a claim that there is no effect or no difference, and alternative hypothesis, the claim for which we seek evidence.